Okay, one more example problem about power. This one is kind of in two parts and hopefully pretty straightforward, and then I'll give you some other useful information. So, as always, I recommend underlining or circling the numbers in your question, maybe even before you read the question, just so you kind of know this is the key parts. So we have a 1,500 kilogram car, and it accelerates to 10 meters per second from a stop in 3 seconds. So before we even look at the question, let's make sure we got this. Okay, so 1,500 kilograms is our mass. So 1,500 kilograms is, oops, erase that. So that's our mass. So I'll just write this up here for quick reference. Then we have 10 meters per second. Make my ones look consistent here. 10 meters per second. That is a velocity. And then we have 3 seconds. I'll write that over here. 3 seconds. That's just a change in time, a delta t. Okay, so what is it actually asking? You might think, oh, I got to find the acceleration, 10 meters per second in 3 seconds, blah, 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 do all that. That's not what you're supposed to do. It says what amount of work was done by the engine. So we need to think about what are our definitions for work. Well, we have one that was force times distance, but it's going to be pretty complicated well, we're definitely going to have to do some work or some math to find the force. We don't really see anything about delta x, so I think it's probably easier to not use that definition, but to use our other definition for work, which is change in energy. And you might think, okay, well, what kinds of energy are we worried about here? We have kinetic energy or we have potential energy. Since we're moving, since I gave you a velocity here, I'm going to go ahead and say kinetic energy is the one we want to use. And so we want the change in kinetic energy, which means we got to do two of them and subtract the difference. So I'm going to say delta E, so change in energy equals, well, first of all, work equals the change in energy, and that equals my kinetic energy at the end. So I'll say that's my second kinetic energy minus how much kinetic energy I had in the first place. And so that would be number one. And you might be thinking, but Mr. Schober, we don't have enough information for all that. You'll see. You're actually going to see this works out to be pretty easy. So let's think, what is our equation for kinetic energy? Okay, kinetic energy is, hopefully you remember, I'm just going to kind of move through this pretty quick, 1/2 times mass times velocity squared. And this is going to be v2 squared. Then we're going to do the same thing, minus 1/2 mass times velocity 1 squared. Okay, and now you're going to be like, Mr. Schober, we only had one velocity in the question. Or did we? It says we were stopped. So from a stop. So when the question begins, we were actually not moving. So if we're not moving, that means our velocity is 0. And if my velocity is 0, this whole thing goes to 0. So we don't have to worry about it. That makes our job really easy. So now what we're going to do is come back over here, and we're going to say, okay, 1/2 is still 1/2. Mass is 1,500 kilograms, so I'll put that in parentheses. 1,500 kilograms times my velocity is 10 meters per second, and I want to square that. And that's going to be my kinetic energy. So let's find that. So clear everything we got here. I'm going to move this over to the side so we can see what we're typing in. So 1/2 is just going to be 1 divided by 2 equals 0.5. We already knew that. Times 1,500 kilograms. So that's 750 times, now this is where it gets a little bit tricky, 10 squared, which is really just 100, equals 75,000. Okay, so now I can come back over here, and this is 75,000, and our unit is, well, you know what? I was about to say watts, but it's not watts because we're not talking about power yet. We're talking about just the energy or the work. So that is how much work was done there. Because we start off with work. We said work is equal to the change in energy. Well, we're only talking about kinetic energy, so we have the final kinetic energy minus the first kinetic energy. Did some math there. This one ended up being 0. We did some multiplication and squaring that, and we get this 75,000 joules is our work. Now, how much power did the engine deliver? Well, that question is now pretty easy. We're going to say power equals work divided by change in time. And we know that work was this number here. So that's 75,000 joules divided by our change in time was 3 seconds equals, and again, I'm just going to go to my calculator for this, although this one's going to be a little bit easier. 75,000 divided by 3 seconds equals 25,000. Okay, so that was nothing too crazy. 25,000. Now, what is the unit that we're talking about? We could say joules per second, and that would be fine, because we had joules right here, and we did joules up here, and we divided by seconds. But instead of doing that, actually, why don't we, sorry, there we go. I'm trying to figure out which tool I want to use. We have a unit that means power, that's just for power, and that is our watts. And so this equals the power. And I know we talked about this before, but this W means, this W here means watts. This W means work. They're not the same thing. That's kind of confusing. Maybe this is a good time to point out how you can tell the difference. This is just by itself, a W by itself, or a W is part of an equation. This one up here, that means it's going to be work. But when you have a number with a W as the unit, that means you're talking about watts. So those are our answers right there, and that should help you on a couple of the example problems, or a couple of the practice problems you're going to have to do.